So good morning, good afternoon, everybody, and welcome to another of our wireless, mobile and digital infrastructure interviews. This one, we have a special guest from Intelsat. Gerry Collins is Director of Product Management for Mobile Networks for Intelsat. I'm in Austin, Texas. He's in the UK somewhere. So this is a truly international interview. I've got several questions for Gerry, but the first one, Gerry, is easy, is who are you and what do you do?
Yeah, so my name is Gerry Collins. As Ian says, I'm from Intelsat. I'm based here in London in the UK, and I'm responsible for the product management for all of our service to our networks customers. We define our networks customers as large enterprises, telcos and ISPs, and also the mobile network operator segment.
Okay, so I think today we're going to chat a lot about the backhaul to cell sites and connectivity and all those good things. I'm going to start with the obvious questions. You're a satellite provider. Your satellite is, I think, 36,000 kilometers that way, geostationary. We hear a lot, from an analyst point of view, we hear a lot about the LEOs and all the low Earth orbit satellites and constellations. So from your perspective, this industry with 5G, I'll back up, is getting very latency obsessed. We talk latency all the time. So from a geostationary point of view, how does latency fit into the story? How do you deal with that?
Yeah, so you're right. We're in a kind of a world where it's latency obsessed. Latency is an issue we've been dealing with for kind of over 55 years. We were the first to launch the first telecommunication satellites. And you're right, they're geostationary. They're up, but they give us, very, very big advantages in terms of their position, so that they remain constant compared to your position on Earth. But they're 36,000 kilometers up. So you automatically have a latency between the end user and the satellite of, do your physics. It's 120 milliseconds. And people go, we're in the 5G world. We're looking to do 10 milliseconds. And obviously there's constellations they're looking at lower Earth orbits and middle Earth orbits. For us, it's really not about you can't defy the laws of physics. You can't make the delay any shorter. But what you can do is actually reduce the impact of the delay on the end user experience, and that's what we've been doing for a hell of a long time. You could say 55 years since we launched the first satellite, and we really look at this in two service categories. How do we limit the impact of that latency on voice, and how do we limit the impact of the latency on data? So starting on the voice side, the good news is that the human perception of the quality of voice really only starts to perceive something as poor quality when they have a latency that approaches between 800 milliseconds and a second. We're obviously, by the time you go up to the satellite, you come down, and then maybe you get your acknowledgement, we're heading towards 500 milliseconds round trip delay. And so essentially the customer can sometimes know that there's a delay, but it doesn't actually impact their end user experience. But what is really, really key for us, it's not the delay, it's the variation of the delay. And many of you, engineers will know, and other people, the variation of the delay is what really impacts the customer experience. And that's called jitter. And once you've obviously got a longer potential delay, the variation of that delay becomes more important. It's the variation of delay that can happen in the Earth equipment and also in the satellite. And if you have big variation in the delay, then you really start to impact customer experience. So one of the things that we've always focused on in Intelsat is to reduce that variation, reduce that jitter to less than 20 milliseconds. And then you start to get a performance which is the equivalent of terrestrial, and the customer really has no idea that it's actually coming over satellite. So that is something that we are very, very strong in. Then on the data side, we people ask us, well, it's a lot of data networks. In order to send more information, they need an acknowledgement from the far end. So if I'm waiting up, down, back again, if I'm waiting those 500 milliseconds of acknowledgement, sometimes the pipe closes down. And that's the way in which TCP works. And TCP, we see it in 3G, we see it in 4G. networks. And you can imagine, well, if we don't get that acknowledgement in the time period that we're expecting, then all of a sudden my end user experience is really going to reduce. But no, we do TCP acceleration, which in the cellular world becomes GTP acceleration, GTP being the tunneling protocol used in cellular networks. And there's a lot of little tricks you can do. It comes under the term of either TCP acceleration or GTP acceleration, whereby you do a little bit of spoofing, and basically the next node in the network, which could be really, really close to you, actually sends the acknowledgement. So the sending side continues to send the information to the far end, almost as similar to what is in UDP traffic, where you have free flowing traffic. So we do these things which are very, very well known and have now been adapted, for example, for cellular networks, to ensure that transmission in a data session continues to flow at the equivalent speed that you get in terrestrial network. So we're able to combat those impacts of latency.
Right. So if I'm a mobile operator and I've got some cell sites, rural areas, it's not economic to put in fiber. Microwave's not an option. I don't have line of sight, etc., etc. So what sort of KPIs can you give me for a satellite link to that cell site?
Yeah, so again, looking at looking at our voice KPIs, looking at our data KPIs. On the voice side, the standard measure of quality on voice is the MOS, the mean opinion scores. Right. A range of kind of from 1 up to 5. Most mobile operators say anything north of 3.5 is pretty good. We deliver anything between 3.8 and 4.0. It is true that it is difficult for us to maybe move further into the kind of 4 point something, but very, very standard delivery, 3.8 to 4.0, and that is a very, very good end user experience and well within the requirement for mobile network operators. So then on the data side, it's really the focus around what is the end user experience. What are they getting as they click the button to watch the video, to download the email, et cetera, et cetera. And with the techniques I talked about earlier on, in terms of GTP acceleration, you're able to accelerate the user session, because that's what the TCP or the GTP protocol is doing. It's a user session. So we've got cases in satellite networks where a user could be using the whole bandwidth of the cell, could be using up to 40, 50, 60 megabits, obviously, if there's no contention from other users. So that limitation gets removed. So we see very similar KPIs in terms of accessing data sessions, maintaining data sessions, even going back to voice. One of the key performance indicators we look at is call duration, and we don't see any difference in mean call duration on a satellite backhaul network to a terrestrial. We see anywhere between a minute and a minute and a half, no real difference. So we get comparable KPIs.
Right. So, I mean, it's interesting if you think about a typical smaller market, rural market cell site, you're not going to be standing there with hundreds of users. You're going to stand there, maybe there's 4 or 5 people, maybe it's in a park, national park or something like this. Or so if you can give me, the user, 10, 15, 20 megabits per second, that's as good as I can get here in Austin, Texas, on a loaded network, right? Yeah,
no, absolutely, and that's what we really, really focus on, is that you get a small new, because the way in which satellite works for cellular backhaul is that you share a pool of capacity, which is dynamically allocated multiple times a second. So for the US, you're sitting there in Austin. You might be using a megabit or a number of megabits of capacity. Then you finish your session. Then all of a sudden, the network is actually allocating that capacity to somebody who maybe might be in New York. And again, they're getting the user experience.
Yeah. So we hear a lot about edge compute. We've looked at it before. You and I have spoken about it before. Edge compute is really good for caching content, putting local applications locally. Operators are deploying edge compute now. So where does edge fit into the architecture for the satellite? It seems to me there'd be some natural tie-ins there.
Well, look, edge computing is very exciting for the satellite industry. As we talked about latency, you and I know that, to deliver that sub 10 millisecond latency that we want to get in 5G, it involves edge compute. So, if we do need to deal with applications that, our geostationary type latency does not meet, then, we're able to work with edge computing so that the actual application and the data being used is actually stored right at the edge of the network. So you're able to deliver the kind of delay characteristics that you want there. So it's very, very compatible with satellite technology. And it's something that's very interesting. Obviously, when we talk about edges, you talk about, well, where is the edge? I guess in the satellite world, it's very easy. Where is the edge? The edge is at the end of the satellite link.
Yeah.
So we look at whether it's the remote enterprise or whether it's the remote cell site, is that's for us the edge. And the edge then all of a sudden becomes particularly a point for caching. We see we see video as such a major application, as dominating 75% of the content on mobile network operators' networks. And one thing the satellite does really well is it distributes video. It distributes video primarily through multicast, and we're very excited about a particular range of applications which push video, multicast video, right down to an edge device at a cell site, at an aggregation point, at the enterprise, anywhere. And then you can either cache that, or you can then stream that locally. Rather than having multiple unicast streams, you can take advantage of the satellite multicast into an edge device that then is used to deliver that content on a video on demand or on a live streaming case. So again, for us, we're excited because it gives us that balance to deliver against the latency requirements. It's exciting because for us, it's very clear what the edge is. And third, we think the applications which are very, very dear to us, which is video delivery, is one that can be part of that edge compute proposition.
Right. It's funny, as you were talking, one of the most common questions we get for edge is, where is the edge? And my answer is always, if you take one more step, you fall off the cliff. That's it. That's the edge.
Yeah, it's straightforward for us. It's where the satellite lands.
Yeah. Yeah, as you were talking about the caching, we've been doing work on edge compute for some time now, and 3 or 4 years ago we were actually looking at retail. Retail is one of the first applications to get edge compute, and one of the big applications is purely economic. A lot of retail stores have low bandwidth connections into them. This retailer didn't want to have to go to a higher bandwidth connection. And so they put in edge compute, and the application was training videos. They were high-tech consumer electronics, and every day there were new training videos for new devices, and so they would just cache them on the server. Somebody would come in for their shift, watch their training video, move on, instead of doing that streaming and that unicasting you're talking about. So that application's alive and well. Applying it to the satellite, it's just changing the backhaul, right? Simple as that.
Yeah, and change the backbone, but hopefully also improving the economics and improving the performance, and getting off what might be a congested terrestrial network. So that's where we see some of the value proposition.
Yeah. So we've talked latency, we've talked bandwidth, we've talked edge. The next thing we have to discuss, of course, is 5G. Everybody wants 5G, wants it now. So where does this conversation fit within a 5G architecture? As the operators, let's say I'm back in that rural operator mode, I'm moving to 5G. How do you support me there going forward? When I'm ready to do that.
Well, again, it's for us. It's the use cases. There are the we talk about what are the value propositions in 5G. There is extended coverage. There's ultra reliable networks. There's broadcast like services. I've talked about broadcast type services. We think also satellite can help to improve the reliability and reach to not just peoples and towers, but also to things such as IoT. And then obviously there's also the backhauling application. So we see broadcast type services, reliability, and then backhauling connectivity. But it's big. It's bigger for us. It's bigger than this. Satellite, a major milestone for the satellite world was in December when the scope of release 17 was released, and there was a
Mhm.
non-terrestrial networks aspect in there.
Right.
This means that the satellite world is moving from a very vertically integrated world where we talk our own language to the other satellite people to moving into a world where we're talking a language to lots of other people and lots of other applications and lots of other verticals. And we will see a rapid change of the whole ecosystem of the way satellite services will be delivered. We see this as an opportunity to become mainstream and bring a lot of the values which are reach, reliability, broadcast type services, bring those values closer to the terrestrial world, and that's what 5G means for us. We think about ourselves first, but also that's what it'll mean. We think to our customers in the cellular world. It'll mean a change of the ecosystem as well. It'll mean new people working on satellite-based solutions. We're already seeing the space industry attracting a lot more interest, a lot more investment. We think that's going to continue, and it's partly be fueled by the fact that non-terrestrial networks are part of 5G. So it's hugely impactful to us, and we hope it's impactful to us, and then it'll also be impactful back into the cellular industry, which hopefully can get some of the benefits of what we can bring.
Right. No, I mean, you're right. If anytime you're getting incorporated into the standards, I mean, obviously the world's operators look at those 3GPP standards and talk about which release they're on and all these things. So being incorporated to that makes you're part of the ecosystem, right?
Yeah, we're part of the ecosystem, part of the club, and we talk the same language. Yes, the world has talked a different language to the terrestrial world for too long. Now we talk the same language, and this is great.
Yeah. All right. So last question here, and you and I have spoken before, I think, so you probably know this one's coming. Maybe not. What keeps you awake at night? What is it that worries you as we look forward to all the things we've talked about, that in a year or two we could look back and say, darn it, we should have done this in the summer of 2020. It would make life much easier for us now. And it could be an industry view, it could be obviously a satellite view, but what is it you think we're not paying enough attention to today?
Look, I'll go back. I go back to what I talked about is what satellite can bring to the cellular world, and again, it's broadcast-like services, reach, and reliability, and I firmly believe I spent 20 years in the cellular world. Over a period of time I transitioned into the satellite world. And I transitioned into the satellite world because I saw there were so many things the satellite world can bring into cellular, things the cellular world can't quite do. It can't quite cover everywhere, the cellular world, but with satellite you make it do it, and you could go through multiple use cases. My biggest concern is that we don't deliver on that, and that we're not going fast enough, and that we will miss this opportunity. And the cellular world will miss it as well, is that if we don't trial these things out, and we don't put the money behind them, and we don't go fast enough, and we don't think a bit differently, that then, we'll be here in 5 years' time, and I'll still be talking about, well, satellite use cases can really add value to the cellular world. But unless we invest now, we look at those, and there's a lot of things going on with video at the moment, and you kind of go, in the satellite world, we know how to do video. We know how to distribute it. And if we miss this opportunity to demonstrate to the cellular world what we can do, then that gets me worried that we'll have missed our big opportunity because it's in front of us now. Yeah.
No, I'd agree with you. I think it's interesting though, because if you are not part of 3GPP release 17, then obviously that task becomes much harder. The fact you are included now as operators are deploying, operators today are deploying that 5G core as part of release 17. So there's a natural step to the discussion with you. It's like, oh, with a non-terrestrial component here, what do we do? So the timing works out really well in terms of deployment, standards, and satellite solution available as well.
Yeah, it's such a good opener in the conversation is that, especially a mobile operator that's never looked at satellite before, you're going to go, we're going to release 17. We're going to be part of your standards. We're going to speak the same language. The points of interoperability or interconnection between our networks and your networks are going to be standardized. You're going to be able to look in your specification book. You'll know exactly how we're going to work with you. And that is great. And my worry was that we wouldn't get through, but then, the reality is the mobile operators voted for the satellite folks to come in.
That's right.
Which is great. It wasn't that we voted ourselves in, it was the mobile operator folks voted us in. So we're appreciative of that. And we want to make the best of it.
Yeah. Well, great. Well, Gerry, thanks very much for the time today. For those watching, we've been chatting with Gerry Collins in London in the UK. My name is Ian Gillett from IGR in Austin, Texas. And Gerry is, I'll get this right, Director, Product Management of Mobile Networks for Intelsat. Gerry, thank you.
That'll do. Okay, thanks very much, Ian. Really enjoyed it.
Thanks.
Bye-bye, everybody.